All right. Good afternoon, everyone. We have a few students in class, most students online. Welcome. Can someone confirm that you can hear me, especially for online students? Can you confirm that you can hear me and you can see my computer? You can see my screen.
Professor, I can't see your screen.
That's the reason I'm asking. Close share screen. Okay. Can you see my screen now?
Yep.
Okay. Thank you. I just want to double check. The lecture is recorded. Okay. Lecture is recorded. I try to open the chat. So if you are in class, because I cannot see you, I'm facing here. Sorry. You just voice up, speak up. If you have any questions, just speak up. Okay. Thank you. So now I can see the chart. Okay. But I need to start. Okay, just typing hello. Okay, so I can type in the message. I can receive your message. You can see my screen. You can hear me. Everything works all right. Okay. Are there any questions, anything before we start? Maybe I will start off by saying something about housekeeping, the logistics of this class. Remember, each week we have 1% participation mark by completing a small exercise. In week 1, everybody got that 1% in week 1. From week 2 onward, you have to submit something in order to earn 1%. I just focus on the big picture, okay? I already marked your participation mark from week 2 to week 5. Last week, week 6, we had midterm. Actually, last week was a reading week. We don't count reading week as academic week, okay? So anyway, I marked your participation mark. Usually I got 17 student submission. If you are one of those 17 students, congratulations. If you are not, I hope you will catch up from this week. You will submit the 1%, okay? So total is 10% toward your final mark. That is 1% participation mark. And the other thing is the assignment posted on Sakai. Okay, so let me pull out my Sakai website. The 10% assignment is due March 17th. You are asked to complete exercise from 10 units. Some units have 2 exercises. Some unit has 1 exercise. You are asked to complete all exercise for that unit. Okay. I hope today we will have some time to help you complete some of the assignment. Okay. So that is 10% assignment. And also a project proposal. The due date is tomorrow. Okay, due date is tomorrow. If you go to Sakai, go to project proposal. What you need to submit? You need to submit one page proposal, including your group member names, student number, project title, your project background, objectives, data collection, and propose quantitative method. For example, are you going to use a t-test? Are you going to use ANOVA test? Are you going to use regressions? Are you going to use discriminant analysis? So what are you going to use? Okay. So those are just one page. Give me the idea. What is your project about? Okay. If you haven't had a group, please try to form a group. Okay. And so that is the group project. And for today, 1%, it is under the, if you click test and quizzes, from today, I will try to put that 1% under the test and quizzes. I try to simulate the format of our final exam. So for example, today I give you two questions. One is a multiple choice question. The other is a true or false. Those are kind of questions will appear on final exam. Okay. And so please make sure you complete this 1% for each week. Can someone confirm you can see week 7 from the test and quiz?
It's only going to be available at 2:30.
Oh, yeah. It is only available at 2. Thank you. Yeah. Okay. Right now you cannot see it. Okay. It's just 2 questions. So that is 1% for each week. And for our final exam, the format of the final exam would be similar to midterm test. Remember, how did you do midterm test? Some questions are multiple choice questions. Some questions are short answer. And some questions need to run SPSS to get the answer. Okay. That is the format of final exam. And our final exam is scheduled on April 26th. That is Tuesday. April 26th at 7 p.m. It is a 3-hour exam. Okay. The location is a VCA, stand for Virtual Computer Lab, VCA. So you don't come to our classroom to write your exam. You can just write the exam at your home, anywhere you like. Okay, virtual classroom. It's like, but make sure you can access SPSS. If you're not sure how to access SPSS through Windows Virtual Desktop, you want to come to school, that's fine, but it is virtual lab. Okay, you can write a test at your comfort home, yes.
So does that mean like a lab like this will be open?
I don't know, actually. That is the exam period. I'm not sure if this lab will be open or not, because our exam is scheduled online. But I believe the lab, you know, the fishbowl, over there, it should be open.
But you're only limited to booking like 2 hours.
For each student?
You can book, but you have to book, but you can stay as long as you want.
Online.
Yeah, it says it gives you that option, but you can stay as long as you want.
Okay.
Okay. So that is the final exam, 3 hours on virtual lab or Windows Virtual Desktop. I don't have much questions about run the SPSS, using SPSS. Most questions, I will give you the output. I will run SPSS on my end. I will give you the output, ask you this question, that question. Okay, just in case you cannot access SPSS, maybe I have just 1 or 2 questions. And that the weight of that question would be very, very light. because I'm considering in case you cannot access Windows Virtual Desktop, I don't want that to cause you a headache. So most questions will be based on the output from SPSS I created from my data file. Is that clear? So you don't worry too much. Okay, I cannot access SPSS. Just 1 or 2 questions, and that question weight does not affect your overall achievement. Okay, so your overall achievement will heavily based on how do you interpret the output from SPSS? That is the focus. Okay, and the course content will be focused on whatever after midterm. Before midterm, you may have about roughly, okay, 20% to 30%, 20% roughly. After midterm, the content will contribute like 80% to your final exam. So today is the first lesson after midterm, so it would be very important. Okay. So that is the final exam. Any questions?
So the final exam, will you open book exam like the midterm?
Thank you. Yes, the final exam will be exactly the same like midterm. Open book, open resources, but it is individual work, not collaboration with other people. Open book, open notes. Okay. Any other questions? So next week, I'll try to give you some questions from SPSS output. I ask you this question, that question as 1% participation mark. Okay, so you can see what kind of question will appear on final exam based on output from SPSS. Okay. All right, so let me check the chat area. If any questions for those students who are online? The final exam content is covered from today. It is 80% focus on weeks 7 to 10. But today is week 7, okay? Today is week 7. I will give you specific announcement once I finalize the final exam questions. Okay, I haven't finalized yet. Once I finalize, I will tell you how many questions multiple choice, how many short answer, how many questions, analyze the output from SPSS. Okay. All right. Okay. So that is some logistics. Any questions? So in summary, keep in mind 1% each week, total 10%, and project proposal due tomorrow midnight. Assignment 1, 10%, not assignment 1, just assignment, 10% due March 17th. Okay, and then we have project due, we have final exam. Okay, so those are the remaining term work. All right, so today we will do discriminant analysis. So let me dive in the discriminant analysis. We are going to use data from our textbook. I will try to analyze, explain the concept and the techniques using the data file. So today is a lesson 35 discriminant analysis. I'll directly jump to the data file. Based on data file, and then we analyze the concept involved. So this is the okay, in our data file from lesson 35, try to grab my pen. We have 1, 2, 3, 4, 5, 6 variables. Okay. We have a friendly variable. We have a GPA, your college GPA. We have a job category variable. This job category is categorical variables. It is category. We have 3 categories. One is poor performance. The second is individual achiever. The third one is team player. We also have a variable called job history, rating from 1 to 10, with 1 represent unimpressive, and 10 represent extremely impressive. And we have a job test. It is percentage correct on our job test. Okay. So we have a total 6 variables. For these 6 variables, we use job category as a Y dependent variable. Okay. So this is our Y. And the other variables are our X. There is another name for Y, also called criteria variable. Okay, this is our Y. And GPA is our X, friendly is our X, job list is X, and job test is X. Those are independent variables. Independent variable has another name, predictors. Okay, try to make it. So we have 1 Y, and then we have X, maybe X1, X2, X3, X4. Those are the X. What we want to, based on the historical data, each person has 6 number, each participants. Okay, because we have total 6 variables. We want to see, based on the variable for X, which are my X, friendly, GPA, job history, job test, can I predict this person's job category based on X? Can I predict Y? That is our question, research question. And that question can be answered using discriminant analysis. Okay, discriminant analysis. So we want to determine whether the false 1, 2, 3, 4, or we have 5 false scores. Okay, friendly GPA, job history, job test. We want to determine whether these false scores are useful for predicting job performance. Okay, so I'm going to type in this up because this is important concept in discriminant analysis. Try to increase the font size. We have 4x, okay, friendly GPA. Job history, job test, whether these 4 scores are useful in predicting job performance, in predicting job category. That is what we want to do, okay? And the total we have, how many people participated? We have 124 cases. So that is our objective. And how do we do that? How do we determine, are you belong to individual achiever or poor performer or team player? How do we do that? We use discriminant functions. Okay. This is just a theoretical concept part. Discriminant functions. And this discriminant functions is produced by the computer, by the SPSS. So how do we determine how many functions do we need? There's a formula, okay? So it is the smaller of number of group. I use NG represent number of group minus 1 and P. And what is P? P represent number of X. P represent number of X. So NG represent number of group. So in our example, can someone identify what is the number P? What is P in our example here? Anyone? Yes, please. Yes, we have 4x. So maybe x1, x2, x3, x4. Okay, so P is number of x. Okay, in our example. So P equal to 4. And then what is NG? Number of groups. What is NG? We have 4 groups. Poor performer, individual achiever, team player. So NG equal to 3. Number of group equal to 3. And the formula said you have to minus 1. So 3 minus 1. 3 minus 1 equal to 2. The smaller number between 2 and 4, in our case, that is 2. So in our example, we should get 2 discriminant functions. We should get 2 discriminant functions. Okay. So what is the discriminant function looks like? Okay. So if I use D represent descriptive functions, it looks like the discriminant function D is the combination of x1, x2, x3, x4, and maybe a constant. Okay, maybe I'll put alpha plus beta 1, beta 2, beta 3, beta 4. something like that. That is my discriminant function. How does it look like? Looks like the regression equation, right? So that is the discriminant function. And then we have a new concept. It is the eigenvalue. So what is eigenvalue? Eigenvalue is the ratio it is the ratio of between groups sums of squares to the within group sums of squares. That is what is eigenvalue. Okay, the ratio between groups over within groups. And the bigger the eigenvalue, the stronger the discriminant function. Okay, so we wish we will have a bigger eigenvalues. So those are some overview of discriminant analysis. Next, we'll talk about assumptions. Assumptions for doing discriminant analysis. Assumption 1, independent variables are normally distributed. Independent variables normally distributed. And assumption 2, population variance are equal. Assumption 3, participants are randomly selected, so it is random sample. So that is assumptions. And then effect size. Oops. The concept of effect size measures how much change in Y can be explained by the combination of X. It is like in multiple regression, you have R squared. Okay, so that one is similar to the meaning of R squared in regression. In other research, we call effect size. It is actually the same as R squared, similar to R squared. All right, so that is the overview of discriminant analysis. Any questions? Okay, now let's go to the data. So I will open the data, lesson 25. 35. 35 data file. I'll click open. Just want to check any questions for the online groups. So any questions? Anyone? Okay, no questions from the chat area. So this is my lesson 20. I will save it as different name. In case something happened, I will have always fresh data available. So I'm going to save this as 25 followed by my initial. All right, so let's do the discriminant analysis. Let's look at the data first. Go to the variable view. Usually the label will give you the meaning of the variable. Friendly is the friendliness. Okay. GPA is the college GPA. Job category, we have 3 job categories. If you click this one is a poor performer. 2, individual achiever. 3, team player. Okay, that is the job category. And then we have job history, job test. So this is the data. So the measurement for each variable, for example, friendliness, the bigger the number, the more friendly this person is, okay? And we all know the meaning of the GPA. The bigger the number, the higher the GPA. Job history, the bigger the number, the more impressive you are with your history. Job test, the bigger the number, the more correct answer you get for the test. So what we want to do, we want to predict job category based on friendly GPA, job history, and job test. That is what we want to do. Okay, we want to divide the people into 3 groups. 3 groups. Job category, individual achiever, poor performer, team player, based on 4 variables. So to do that, you go to analyze, classify, and then discriminate. So now we need to put a grouping variable. So guess which one is the grouping variable? Anyone? Yes?
Job category.
Thank you. Job category is grouping variable. And then you have to define group, define the range. Remember we have 1, 2, 3. Minimum value is 1. Maximum value is 3. And then click continue. And the independent variable, that is our X. We have 4X. By press and hold down Shift, you can select all 4 variables together. Shift button allow you to select all variables together. And then click this button. Or you can drag them individually. Any questions so far? Now, quick statistics. And we want the mean value. We also want univariate ANOVA. And we need box M. Box M is a statistic that checks the assumption 2 for discriminant analysis. Remember what is the assumptions? Population variance are equal. That is assumption 2. Population variance are equal. We can use the box M to do that. So box M to ensure assumption 2 is satisfied. After that, we select features and unstandardized under function coefficients. So features, we use those coefficients when we use the discriminant functions. Remember, the discriminant functions has the coefficient here. Beta 1, beta 2, those are the coefficients for discriminant functions. So we use features coefficients. After that, we click continue. And then you click classify. Under the classify, remember in our question, we have 3 groups: individual achiever, poor performer. We have these 3 groups and team player. Okay. And so for these 3 groups, we want to compute the mean value. But we do not know how many people in group 1, how many people. Remember, total people we know. Total people is 124. Total participants, okay? But we don't know if those 3 groups are equal or not, number of people in each group. So we use this option, compute from group size, because we don't know if all groups are equal. We don't know. We select these options. If you know all groups are equal, you can select the first one. And then on the plots, we also want to create some plots. Select combined groups. In your assignment, one question is on chapter lesson 35, asks you to create a combined group plot. So this is the chance you select combined group. You cannot do the plot from graph, only from here. For discriminant analysis, the plot will be produced here using combined groups. And also separate groups. And make sure within groups is selected under the covariance matrix. Now click, and then click summary table. We also need a summary table. And then leave one out, classification. What does it mean, leave one out? Means each case in the analysis is classified by the functions derived from all cases rather than that case. I will write it down. What does it mean, leave one out? I'll try to make the font bigger. Leave one out classification means each case in the analysis is classified by the function derived from all cases other than that case. This leave one out, also called U method, also known as U method. Some textbook or research paper called U method. So that is leave one out. And then click continue. After that, click save button. Save, S-A-V-E, save. What do we want to save? We want to save predicted membership. This is our research question. We want to say which person belongs to which group. Person A belongs to group 1 or group 2 or group 3. Person 2 belongs to group 1 or group 2, group 3. We want to see that. Okay. And remember, how do we put people in group? We based on discrimination functions. And we also want to see that scores. And then if you want, you can also select probabilities of group membership. In our example, we have 3 groups: individual achiever, poor performer, and team player. So click continue button. Okay. And then click OK button. And we have the output. Any questions on the procedure? I will explain output maybe later. But now I want to say something about the data file here. See, the data file looks different from we opened it. When we open the data file, we only have those variables. But now we have the prediction. So for example, person one belongs to group 1, poor performer. Person 2 belongs to group 3, team player. Okay. Person 5 belongs to group 2, individual achiever. So those are our prediction. It is remember we click the save button, the result saved to the original data. And this is our discriminant. Remember when we analyze, before we do, we say in our example, we have 2 discriminant functions. We have 2 functions, discriminant functions. Oops. And this is our function 1 score. This is our function 2 score. Those are discriminant functions, okay? Function 1, function 2. And those are the probability for group 1, the probability for group 2, the probability for group 3. Okay, so let's analyze why the computer assigned the first person group 1. If you look at the probability for person 1 belong to group 1 is 0.86. The probability for person 1 belong to group 2 0.022. The probability for the first person belong to group 3, that is 0.11. If I ask you to assign person 1 to a group based on probability, what would you assign these people? Based on probability. Anyone? Yes?
Group 1?
Yes, why?
Because it has the highest probability by a significant margin.
Excellent. Group 1, the 4 people who belong to group 1 because out of this probability for group 1, probability for group 2, probability for group 3, you pick the highest probability. That is that person belong to. Okay? Now let's check the second person. The second person belong to group 3. We predict belong to group 3. Why? Anyone? Do I have some online students you want to make contribution? Why the second person is predicted to belong to group 3? Anyone? This probably final exam question. I give you the output. I ask you to predict this person belong to which group. Okay, I will repeat, give you the hint. My question was, this is the second person. How do you predict the second person belong to group 1 or group 2 or group 3? Look at the probability. The second person, the probability belong to group 1, 0.25. The second person, the probability belong to group 2, 0.069. The second person, the probability of belonging to group 3, 0.67. You tell me the second person belong to which group? Yes. Perfect. I hope everyone got this based on probability. Okay. Okay, now I will ask volunteer. I have the fifth group, not fifth group, the fifth people. How do you predict the fifth person I highlighted here belong to which group? Yes.
Second group because they have the highest probability.
Thank you so much. So this person belong to second group because you see, this person belong to group 1, probability 0.045. This person belong to group 2, probability 0.87. And this person belong to group 2 or 3. The probability 0.07. So the final answer group 2. This person belong to group 2. Okay, make sure you get it, because final exam, I'm telling you, focus on this week, next week, the week after, and our last week. We have 4 weeks left, including today. This must have a question in final exam. I give you output. I ask you, what does this person belong to, which group? What you are looking for, probability, okay? All right, so this is just part of the output. The other output, remember we have lots of output here. Okay, and we are going to analyze this output after break. Okay, so shall we all take 10 minutes break? Make sure you stretch, get some fresh air, drink water. The next session will resume at 2 o'clock. Okay. So for those online, break time now, okay? 10 minutes break. So I'm going to stop recording. When we come back, I will quick record button again.